Hello students, welcome back. I'm Arijit sir in my channel Arijit Ghosh Chemistry Online. Today we are going to learn Reimer Tiemann reaction with its mechanism. Actually for the CBSE students, your mechanism is to come right in the reaction. Okay, now we are starting. Reimer Tiemann reaction actually form phenol when reacts with chloroform and caustic soda. Okay, so phenol reacts with chloroform in presence of sodium hydroxide or caustic soda at around temperature 65 to 75 degrees centigrade. When heated, it actually forms this ortho-hydroxy benzaldehyde. This is we used to call the salicylaldehyde, ortho-hydroxy benzaldehyde or salicylaldehyde. Okay, and a para formation also para-hydroxy benzaldehyde. Okay students, so this is actually our Reimer Tiemann reaction. Now I am going to show you how actually this Reimer Tiemann reaction takes place with its mechanism. Okay, so now I am going to discuss the mechanism. Now students, due to the presence of base, actually first this phenol in presence of base, that is OH minus, this hydrogen is get trapped and it forms the phenate ion. Okay, you can see this phenate ion first forms. Now in presence of actually the chloroform also, this is our chloroform. This base actually converts this chloroform into CCl3 minus also. CCl3 minus. Okay students, now this CCl3 minus actually forms a dichlorocarbene, the electrophile that will actually being attacked. Okay, this CCl3 minus actually form dichlorocarbene. This is our dichlorocarbene, and then chloride ion gets rid of it. Okay, this dichlorocarbene actually will be attacked by this phenate ion. Okay, now you can see phenate ion this is our phenate ion. Phenate ion first due to resonance system it forms this formation. Okay, and this minus actually attacks this CCl2, and this one is actually electrophile. Okay, so this is as nucleophile. This phenate ion actually attacks this one to form this CCl2 design, and then CCl2 minus. Okay, and then due to the presence of H plus ion, and this hydrogen ion will be positive over here, and then the plus minus H plus ion, and then this bond will break again to form this one. Okay students, now in presence of again OH minus hydroxyl ion, in the presence of hydroxyl ion, these two chloride ions converted into these two chloride ions are converted into CH OH whole 2. Okay, students. Now, one carbon cannot contain two OH minus ions, so that's why this one will get rid of the water. Okay, and this one, when gets rid of water, it actually forms you can see. Okay, then in presence of dilute acid, it actually transforms into OH and CHO, and this is how actually the ortho position get attacked by the CHO. Actually here this is the method, the mechanism where ortho position, this is how the which CHO actually gets in the entrance in the ortho position. And whenever in this ion, whenever the actually this minus actually being taking place from here to here, then the para position will be get attacked. Okay, this para position gets minus, and then with CCl2, this para position will attack, then in the similar formation it will form the CHO, that is para-hydroxy benzaldehyde, and this is ortho-hydroxy benzaldehyde. This is the method when the para position is attacked, and this is the method when the ortho position is attacked. So students, this is the method how actually salicylaldehyde actually forms, that is ortho-hydroxy benzaldehyde and para-hydroxy benzaldehyde actually form, and this is the mechanism. Okay, and instead of chloroform, if we use, say for example, instead of chloroform, if we use carbon tetrachloride in a similar condition with base, then it will form the salicylic acid and its para isomer. Okay, students, this one is the salicylic acid and its para isomer. So this is our salicylic acid. Okay, now in case of salicylic acid, I have already done it for you. You can see the mechanism. It will form the CCl3 minus. Now whenever the CCl3 minus is forming, then you can see from here actually it is forming the CCl3. This is the actual formation system. Okay, now in presence of this H plus H plus and minus H plus, then it will form this CHCl3 and O minus. Okay, now there will be actually in presence of base 3 OH. Okay, but you can see one carbon cannot contain 3 OHs at a time, so it will remove one of the OH from here to form COOH. Okay, this is actually our salicylic acid. Whenever dilute acid is given, then it will produce the actual salicylic acid. And similarly, students, you can see the para isomer will also form. Okay, students, so up to this point you should understand actually how we have already produced this Reimer Tiemann reaction. So this is actually the method how to react with the Reimer Tiemann reaction, and the mechanism I have already shown it to you. Hope you like this video, students. So please subscribe my channel and like and comment in it. Thank you, students. Have a nice day.